Okay, in this video I'm going to talk about the sum of angles of a polygon. So basically if you have a polygon, like any polygon, something like this, then with n, let's say polygon with n vertices. N vertices, then the sum of its angles is equal to 180 degrees multiplied by n minus 2. So the theorem is that the sum of angles of a polygon. Okay, let's remove this. With n vertices is equal to 180 degrees multiplied by n minus 2. So that's the theorem. So again, the polygon doesn't have to be regular, doesn't have to be convex, like it can be any polygon at all. So let's consider the proof. The proof is basically induction on n. So by induction. So when n is equal to 3, this is the base of induction. This is the famous theorem that the sum of angles of a triangle is equal to 180 degrees. So n minus 2 becomes 1. And so like we can say that it's a famous theorem, but like it's like I always proved it in a previous video. So see the previous video, and like just as a reminder, the idea of the proof is that we draw a line parallel to one of the sides through the third vertex, and we see that these angles are equal, these angles are equal, and then the sum of angles of a triangle would be equal to these three angles, which in total constitute the full angles of a line. The full angle, like this angle, it's 180 degrees. Yeah, so the base case, so we have the base case of induction, then the induction step. So we assume that that the statement is true. It is true for n, and we consider it for consider the statement for n plus 1. Right, so we have a polygon with n plus 1 vertices. So, and what we do now is we take basically any vertex. Like, well, one way to do it would be like to pick a vertex that would have a would have an angle less than 180 degrees, so kind of a convex angle. But like we would need to prove that such an angle exists. So like we will not do that. Like we will consider both cases. So when the angle is convex and when it's not convex. So so if it's less than 180 degrees, so an angle like this, so then basically we cut this triangle from the polygon, and the rest of the then the rest of the triangle would have, the rest of the polygon would have one less vertex, right? So we removed basically one vertex. So this remaining polygon would have n vertices, and for it we have the sum of angles is equal to 180 degrees multiplied by n minus 2. And we need, when we add back this triangle that I highlighted, we need to add back the sum of its angles, right? So because this angle is part of this angle in the polygon, this angle is part of this angle in the polygon. So we need to add back the sum of the angles of this triangle. So it's 180 degrees for any triangle. Therefore, in total, we have 180 degrees multiplied by n minus 1, which is exactly what we need for n plus 1. So this proves the step of induction for the case of a convex angle. Now, if we have, technically we need to consider 3 cases, not 2 cases. So then we need to consider a case when the angle is exactly 180 degrees. So we have some polygon here, and the angle is exactly 180 degrees. So this case is kind of trivial because we just remove this vertex, and consider this as a single side, right? Then the sum of angles would be again 180 degrees multiplied by m minus 2, and we add back this 180 degrees, the angle that we removed. And again, this would be 180 multiplied by n minus 1. And by the way, the reason why we need this, so even if we kind of don't consider it as a polygon, because it's kind of not clear if this should be even a polygon, considered as a polygon, we need this case for, when we remove, for example, in this case, when we remove this additional triangle, it could be that in the remaining polygon, the resulting angle would be 180 degrees for one of the vertices. So we need this case, even if we don't consider it as a valid polygon. But I think it should be considered as a valid polygon. And the third case, okay, so let's write here. Case 1, case 2, and now the third case is when we have an angle that is greater than 180 degrees. So when we have something like this, then there is a polygon. So this is the angle that we consider now. So to remove it, we remove this triangle, but now this triangle is outside of the polygon. So we need not to, when we add back this the sum of angles of this triangle, we need to be careful what we add and what we subtract. So again, for the remaining for the resulting polygon with one less vertex, we have the sum of angles is 180 degrees multiplied by n minus 2. And then we have, so now let's consider what we need to add and what we need to subtract. So let me remove this and denote the angles of this triangle as alpha, beta, and gamma. Alpha, beta, and gamma. And so we know that the sum of its angles, so alpha plus beta plus gamma is 180 degrees, as for any triangle. And so what we need to add, basically, we need to add this angle, and then we need to subtract alpha and subtract gamma, right? So because this triangle is outside of the polygon, so we need to subtract from this we need to subtract alpha, subtract gamma, but add this angle, which is 360 minus beta. So that's what we need to add. And this is equal to what? Let's calculate this. So 180 by n minus 2 plus 360 minus alpha plus beta plus gamma, right? And so this is 180. So in total we have 180 by n minus 2 plus 360 minus 180. And this is equal to 180 by n minus 2 plus 180. And this is equal to 180 by n minus 1. So this is exactly what we need. So this concludes the proof.